Hi there. Today we are going to talk about how to find the GCF and LCM of a set of numbers and how to apply that information to solving GCF and LCM word problems. LCM stands for least common multiple. A multiple is a result of multiplying a number by an integer. For example, multiples of 8 are 8, 16, 24, 32, and 40. So I would say 8 times 1 equals 8, 8 times 2 equals 16, 8 times 3 equals 24, 8 times 4 equals 32, 8 times 5 equals 40, and so on. Multiples of 12 are 12, 24, 36, 48, and so on. The least common multiple of 8 and 12 would be the smallest number you see in both lists, and the smallest number that I see in both lists is 24. 24 is a multiple of 8, and it is also a multiple of 12. So the LCM is equal to 24. Greatest common factor. Factors are numbers that we multiply together to get a product. For example, factors of 8 are 1, 2, 4, and 8. Factor pairs would be 1 times 8, 2 times 4. Factors of 12 are 1, 2, 3, 4, 6, and 12. And so the factor pairs would be 1 times 12, 2 times 6, and 3 times 4. The GCF of 8 and 12 would be the largest number you see in both lists. The numbers that I see in both lists are 1, 2, and 4. So 8 and 12 have 3 factors in common, but the greatest common factor is 4. So the GCF is equal to 4. Keywords for LCM word problems could be least or smallest. LCM word problems may ask you about having the same amount of each item or when something will happen again at the same time. GCF word problem keywords are greatest and largest. GCF word problems may ask you to arrange something in groups or rows, split or divide items into a smaller section or group, or to equally distribute 2 or more sets of items into their largest grouping. Alicia and a friend are planning a party, and Alicia is in charge of sending out party invitations. The invitations come in packs of 6. And the envelopes come in packs of 15. What is the least amount of each product Alicia will have to purchase in order to have the same number of invitations and envelopes with none left over? So let's pretend that we are with Alicia and she's at the store and she purchases 1 pack of invitations and 1 package of envelopes. So that would give Alicia 6 invitations and 15 envelopes. That is her dilemma. She has more envelopes than invitations, and she would like to have the same number of invitations as envelopes. So she's going to purchase a second package of invitations, and so that would give her 12 invitations. A third pack of invitations would give her 6, 12, 18 invitations. So at this point, she has 18 invitations and 15 envelopes. She still does not have the same amount of each. So if she purchases a second package of envelopes, then she's going to have 30 envelopes and only 18 invitations. So she needs to purchase more invitations. So a fourth pack of invitations would give her 6, 12, 18, 24 invitations. A fifth package of invitations would give her 6, 12, 18, 24, 30 invitations. So our least common multiple is 30. However, the question asks us, what is the least amount of each product Alicia will have to purchase in order to have the same number of invitations and envelopes with none left over? So she will have to purchase 5 packs of invitations and 2 packs of envelopes, and she will have 30 invitations and 30 envelopes. After much contemplating, Alicia and Jennifer decide that they would like to serve hamburgers, meatballs, pasta salads, chips, and dip, and assorted drinks at the party. They visit their local grocery store and discover that hamburger patties are sold in packages of 8, and hamburger buns can be purchased in packages of 10. How many packages of each will they need to purchase in order to get the least amount of each and to ensure each hamburger patty will have a hamburger bun without any left over? So I'm going to go through and underline key information. I need to know that the patties are sold in packages of 8 and that the hamburger buns are sold in packages of 10. And our question is, how many packages of each will they need to purchase in order to get the least amount of each and to ensure each hamburger patty will have a hamburger bun without any left over? So hamburger patties are sold in packages of 8. So if Alicia and Jennifer, purchases 1 package of patties, that would be 8 patties. If they purchase 1 package of buns, that would be 10 hamburger buns. 2 packages of patties would be 16. There would be 16 patties. 3 packages would be 24. 4 packages would be 8, 16, 24, 32, and 5 packages would be 40. 6 packages would be 48. Okay, so 8, 16, 24, 32, 40, 48. I've listed multiples of 8. If I were to list multiples of 10, I would have 10, 20, 30, 40, 50, 60. Okay, so I'm looking for the number that I see in both lists, a common multiple, and the common multiple is 40. But that's not our answer. So this particular problem is asking us how many packages of each will they need to get to the LCM or to have the LCM. And so that would be 5 packages of patties and 4 packs of buns. Jennifer and Alicia purchased 40 gold balloons and 24 silver balloons for their birthday party. They plan on arranging the balloons into colorful balloon bouquets and then placing them around the perimeter of their party room. They would like to have the same number of gold and silver balloons in each balloon bouquet. What is the greatest amount of bouquets that they can make without having any balloons left over? How many of each color will be in each bouquet? I'm going to go through my word problem and underline key information. We need to know that there are 40 gold balloons and 24 silver balloons. They would like to have the same number of gold and silver balloons in each balloon bouquet. And we would like to know what is the greatest amount of bouquets they can make without having any balloons left over, so none left over, and then how many of each color will be in each bouquet. So this is a GCF type word problem. I have gold balloons and silver balloons. There are 40 gold balloons, 24 silver balloons. The method that I'm going to use right now is the ladder method. So I want to find a common factor of 40 and 24. So 4 comes to mind. So I'm going to put 4 on the outside. How many times does 4 fit into 40? It fits in there 10 times. 4 divided into 40 would be 10, and 4 divided into 24 would be 6. Draw another layer because 10 and 6 have a common factor of 2. 2 will go into 10 5 times, and 2 will fit into 6 3 times. 5 and 3. When I think about the factors of 5 and 3, the only common factor they have is 1, so I do not draw an additional layer. The GCF is on the left, so I have 2 numbers on the left, so I would take the 4 and multiply it by the 2. So the GCF equals 4 times 2, which is 8. That also means when it says what is the greatest amount of bouquets that they can make without having any balloons left over, then that's 8. They can have 8 balloon bouquets. And the second question is how many of each color will be in each bouquet? And if you look at the bottom of the ladder diagram, it shows you there's going to be 5 gold balloons and 3 silver balloons each. Okay? Because 5 times 8 is 40 and 3 times 8 is 24. So the answer is 8 balloon bouquets with 5 gold and 3 silver balloons each. There will be a total of 45 friends attending Jennifer's and Alicia's party. 27 girls and 18 boys. The hosts plan on playing several games that require teams. They would like to have co-ed teams that include the same number of girls and the same number of boys on each team. What is the greatest number of teams that could be formed? How many boys would be on each team? How many girls? So the information that we need to be aware of is that there are 27 girls and 18 boys. The hosts plan on playing several games that require teams. And we want to know what is the greatest number of teams, so this will be a GCF problem, that could be formed, and how many boys would be on each team and how many girls. I'm going to complete a ladder diagram for this problem. I know that there are 27 girls and 18 boys. So I want to think about what factors does 27 and 18 have in common. Both numbers are divisible by 3, so I'm going to put my 3 on the outside. 3 will go into 27 9 times. 3 will go into 18 6 times, because 9 times 3 is 27, 6 times 3 is 18. When you think about 9 and 6, what common factors do they have? Is it a common factor other than 1? If so, you draw an additional layer. And you think about what that common factor is. It's 3. 3 will go into 9 3 times. 3 will go into 6 2 times. 3 and 2, the only common factor of 3 and 2 is 1. So we do not need to draw an additional layer. We can end our ladder diagram here. The GCF is on the left. There's 2 numbers on the left. So the GCF is equal to 3 times 3, which is 9. So our GCF is 9. So what is the greatest number of teams that could be formed? 9 teams. How many boys would be on each team? So on each team there would be 2 boys. Look at the bottom of your ladder diagram. So 9 teams with 2 boys and 3 girls on each team.